Good morning, students. Our today's topic in the subject of Pure Mathematics 1 is the types of the roots. So the nature of the roots can be decided by using the discriminant that is b square minus 4ac. So first there are some concepts which need to be understood and learned are. So the discriminant help us to determine nature of the roots. And here is the discriminant, that is b square minus 4ac. If this is greater than 0, then the type of the roots will be real and distinct, and its geometrical interpretation will be curve meet the x-axis at two different points. If the discriminant becomes equal to 0, then the roots will be real and equal, that is coincident, and the geometrical interpretation for this one is x-axis is tangent to the curve or x-axis touches the curve. The next type is if discriminant b square minus 4ac is lesser than 0, then the type of the roots will be not real and or complex, and the geometrical interpretation will be curve does not cross the x-axis or curve is either above or below the x-axis. And the last case is if discriminant becomes greater than or equal to 0, then the type of the roots will be real. Okay, here is a question now, that is 3x square minus x plus 4 equal to 0, and the requirement is find the nature of the roots. Okay, first we are going to check what are the values of a and b. So a is 3, b is minus 1, and c is 4. And now we are going to put the values into discriminant. So b square minus 4ac. And now we are going to put the values of ABC into this one. So B is minus 1. So it will be minus 1 square. Minus 4 as it is. A is 3. And C is 4. So from here, 1 minus 4 3s are 12. And 12 4s are 48. So answer is minus 47, which is lesser than 0. So it means discriminant's answer is lesser than 0. So the roots are not real. So this will be the answer. Roots are not real. Here is another question, and the requirement is same. Find the nature of the roots. So from here, A is 2, B is 1, and C is minus 7. Now we are going to put the values into discriminant. So discriminant is b square minus 4ac. Now putting these values into the discriminant, so b is 1, so 1 square, minus 4 as it is, a is 2, and c is minus 7. Solving it now, so it is 1 minus minus plus, 4 2s are 8, 8 7s are 56, so 57, which is greater than 0. So discriminant is greater than 0. It means roots are real and distinct. So roots are real and distinct. Here is another question, and the requirement is same. Find the nature of the roots. So this is again a quadratic equation. For first we will find the values of a, b, c. A is 1, b is 2, and c is also 1. So now we are going to use the discriminant that will decide the nature of the roots. So discriminant is b square minus 4ac. Now putting the values into the discriminant, so b is 2, so 2 square, minus 4 into a is 1, and c is also 1. So from here 4 minus 4, which is equal to 0. So discriminant is 0. So this is the case. Roots will be real and equal. So roots are real and equal. Here is another question. Statement is find the values of p for which the quadratic equation x square plus 2 plus px plus 13 minus p equal to 0 has equal roots. For these values of p, find the roots. Okay, equal roots. So solution is here. For equal roots, discriminant is equal to 0. So it means b square minus 4ac is equal to 0. From the equation, we can see the coefficient of the x square is 1. So it means a is 1, b is 2 plus p, and c is 13 minus p. So these are the values which are going to be put in the discriminant. So b is 2 plus p. So look now, 2 plus p whole square minus 4 into a is 1 and c is 13 minus p. So now we are going to solve it. So here a plus b whole square formula will be applied. So a square plus b square plus 2ab, and this 4 is going to be multiplied inside the bracket. So 13 fours are 52, minus minus plus 4p equal to 0. From here p square, this 4p and 4p will become 8p now, and this plus 4 and minus 52 is minus 48 equal to 0 is still there. At this step, we are going to solve the equation through the factorization method. Multiply the coefficient of the first one with the last one. So 48, central coefficient is 8. Now think a pair of numbers whose multiplication equal to this one, addition or subtraction equal to this one. So 12 and 4. Okay, write the variable of the singular variable with both these two values. This sign is minus, so the both values will have the two values will have opposite sign, and this sign is showing that this will be placed with the greater value and opposite will be with the lesser value. So this pair of the values will be written at place of this. So p square plus 2p, sorry, plus 12p minus 4p minus 48 equal to 0. At this step, make pairs. So look now, in first pair p is common, so p into remainder is p plus 12, and in second pair, before taking common, this minus sign will be taken here, and now 4 is common, and the remainder will be p plus 12 equal to 0 as it is. So these two brackets are same. One will be written out of these two brackets, and the values outside the bracket will be written in the second bracket equal to 0 as it is. And from here, p will be equal to minus 12 and plus 4. So these are the values of p. So half question is done. Next requirement is find the roots for these values of p. Okay, so when p is equal to minus 12, so put this p into the question. So x square, p is minus 12, so minus 12 plus 2 minus 10, so minus 10x, and p is minus 12, so minus minus plus, uh, this will be 25, so plus 25 equal to 0 as it is. And if you look at the equation, this is actually x plus x minus 5 whole square equal to 0 is still there. And from here you can see the value of the x is 5, because taking square root of both sides, so x minus 5 will be equal to 0, and from there x will be equal to 5. Okay, now the second value is when p is equal to 4. So putting p into the equation, so x square plus, here 4 will be put, so 6x, x square plus 6x, and 4 will be put here, so 13 minus 4 will be 9, so plus 9 equal to 0. If you look at this equation, this is actually x plus 3 whole square equal to 0 is still there. Taking square root of both sides, so x plus 3 will be equal to 0, and from here x is equal to minus 3. So these are the roots when p is minus 12 and 4.